I'm super excited to welcome Byron Cook to the workshop. We are very lucky to have him. Byron is very well known in the area of program analysis, program verification, with a number of fundamental contribution to the area, including verification, automated verification of safety properties, liveness properties, termination, as a number of classic works and tools in the area. He's received many awards on this topic, including the Roger Needham Award, and he's currently a vice president and distinguished scientist at Amazon, and also a professor at University of College London. So I'm really super excited to have Byron here, and we should all be very happy. And Byron, please go ahead.
Thanks. Let me share my screen. Okay, great. Thank you very much. So this is an experimental talk. This may be a colossal failure, but I'm going to try something a little unusual and perhaps a little controversial. It's a little meta. It's sort of at the intersection of organizational theory, formal verification, business, psychology, and I guess it's sort of, I'm doing it because unfortunately, I've found that the non-technical aspects sometimes disproportionately affect your ability to deliver the technical bits. So I'm sort of mixing them up a little bit. So it's a largely non-technical talk, but sometimes the most influential ideas are non-technical. But it's definitely aimed at a formal verification, programming languages crowd. So there you go. And along the way, I'll be pointing to technical papers. So it comes out of, so I'm giving talks, I was the Flock plenary speaker, and I gave an invited talk at Uppsala, and Peter Muller and I had a nice discussion at the PLDI, and Ask Me Anything, and I was interviewed on theCUBE and so on. And the question that always comes out, is, Byron, why has Amazon been so successful in formal reasoning when others in the software space haven't? So what's happening is that they're looking at the results, and I'll give you a quick summary of the results, but they're looking at the results and they see that in hardware, the formal verification is now pretty big business with things like Jasper Gold. And then in niche domains like software, like in aerospace, formal verification is used, but you really don't see it in general software at the scale that I think a lot of us would like to see it. And then suddenly Amazon seems to be doing it pretty much at scale, and people are just really puzzled, myself included. So that's the question I'm going to try and answer. So what's like when I've given my normal invited talk, you would see that the Chief Information Security Officer of Amazon's cloud provider AWS, and the CEO and the CTO and the Vice President of Identity are all speaking about automated reasoning in front of really big crowds, or nowadays, because of the pandemic, they're giving streaming talks, and they're viewed by huge numbers of people. And then here's the Vice President and Distinguished Engineer of AWS's security organization giving his own talk for an hour about how important automated reasoning is to security of AWS. And then in the compliance space, same thing. So here's the Vice President of AWS's compliance organization, together with the CEO of one of our third-party compliance auditors, again, talking about how important formal verification is. And then there's many examples of customer-facing features now, AWS customers. So VPC Reachability Analyzer, and Managed Config Rules, and S3 Block Public Access, and IAM Access Analyzer, and IoT Events, and the list goes on. And if you look at the product categories from AWS, basically all of them are touched by automated reasoning in some way now. So for example, this is I think a CAV 2018 paper about our proofs of the TLS implementation that's used across Amazon called S2N, and that work has continued. So here's a recent CAV paper on reasoning about the AWS libcrypto. So what's happened is that we've assembled a large and growing formal methods team. There are hundreds of full-time formal methods scientists on staff nowadays. This year, we had 70 PhD student interns. And every year, things seem to grow between 50% year over year to 100% year over year. So this number could easily double next year. And so there's way too many people to, there's hundreds of people to list. And so I'm sure that some of you have friends that are working in the organization. Here's just the most senior people. So this is the people with principal in their title. And there's more joining all the time. So you may know some of these people, and there's more joining all the time. So for example, Robert Jones is starting this month. And then we also have a number of academics who are with us part-time. So they're usually with us at least 20% of their time, and they often up their time during summer. So when they have sabbaticals and they come full-time. Then we also have a number of academic collaborations. So here, for example, are folks that received financial support from us in spring. So we're working across a variety of areas from, like we've hired a lot of the people who work in Rust, and so programming languages and reasoning about programming languages and reasoning about microprocessors and internal networks and virtualized networks that customers build, and our storage infrastructure, and identity and authorization and crypto and protocols, you name it. So that goes on and on and on. So that's what, people see that and they're like, how is that happening? And so I think that these Amazon concepts have been really crucial to our success. There's 4 concepts that very much come from Amazon, and kind of by luck, when I ended up joining, I didn't really understand any of this, but these concepts have been really key. So the goal of this talk is what I would love to achieve is to find models that can be used outside of Amazon. So to interpolate some of the great ideas from inside Amazon outside, such that if you're at university, or you're at a different, you're in government, or you're in a different company doing this kind of work, that you could also adapt some of the things that we've stumbled upon that have been really influential in helping us be successful with formal methods. Another goal I have is that, thoughts for the young folks. So people just starting their career. I wanted to try, and I'm not sure if I'll be successful, but I'm going to try and convey some of the things that have helped us, and then that maybe you can put that'll help you out in your career somehow. And then we have a lot of professors sending their students to Amazon, so obviously it'll be helpful context. And then there's a lot of folks, we have a lot of collaborations outside. So a lot of you will be working with people inside, and so to understand the context of how things are working on inside may help you out. So that's the goal. But remember, I'm not sure if I'll succeed. So I may raise more questions than answers, but that's good. So maybe we'll have a good Q&A. So I'm just going to go through each of these and describe them. So the first one is this idea called a virtuous cycle. And if you Google Amazon virtuous cycle, you're going to see talks, and you're going to see books, and you're going to see dissertations from MBAs and case studies and so on. So it's a pretty well-known idea. And the idea is take any of these concepts. So think Amazon.com. Take any of that. Take traffic. So if there's a lot of traffic coming in Amazon.com, that's going to attract more sellers. And then if there's more sellers, then that's going to make for more selection. And if there's more selection, then that'll make for a better customer experience. And then there's a greater customer experience that will drive more traffic, which then attracts more sellers, which then makes for more selection. So this is a virtuous cycle that grows. And then the really interesting aspect is that with growth, there's opportunities to lower your cost structure. So you can refactor the business, get better utilization, economies of scale, what have you. That lowers prices, and then that makes for a better customer experience. So this is really the thing that drives Amazon. So Amazon leaders are on the lookout for virtuous cycles. This is how Amazon's thinking about business. And you can take any Amazon product and kind of work out how they're thinking about the virtuous cycle. So Prime, for example, in some countries we have a subscription program called Prime, and if you sign up, then you get extra benefits. So the goal there is, what can we, with more people signing up for Prime, that attracts more sellers that will participate with Prime, which makes more selection. which makes for better customer experience, which then makes for better traffic. And then Amazon can lower its cost structure with regards to Prime by, for example, reconfiguring how they organize the fulfillment centers or whatever, which then lowers prices, which then makes for a better customer experience. So that's the basic idea. And then a really fascinating example of this is an example of refactor was Amazon Web Services itself. So all these Amazon businesses were using what is essentially what is AWS today. And they're like, oh, wait, if we refactor that we can now get more economies of scale, which will lower the cost, which will then allow these other businesses to operate at lower cost. So again, virtuous cycle. So AWS was really more of a business innovation and less of a technical one, if you think about it. Like there's a bunch of really cool technology going on underneath, but the first move or the sort of first interesting aspect is really more of a business idea than a technical idea. And this drives this really interesting line of thinking that I think to many of us informal methods will be foreign. So it drives a strategy where you're looking for low margin, high volume, right? Because when you're, imagine you don't lower prices, then that's going to not make as good of a customer experience. Well, then you'll have less traffic, and that flywheel will grow slower, will move slower. So you're wanting to lower prices because you're going to make it back up on volume. So if you look at Amazon in comparison to other companies, so here I put the Fortune 5 companies together with a few other companies that if you're aware of AWS, you would typically associate AWS with. And if you sort of look at this graph for a while, this is the profit margins reported in the past, their last reporting for the different companies. If you look at the profit margins, you'll see there's kind of two different kinds of companies. There's high margin companies and low margin companies. And so the high margin companies are more in the tech space, and the low margin companies are less in the tech space. And you'll notice that Amazon is actually much more of a low margin company. So now this idea can be applied to tech. So it can really be any technology or product. So an example of this is S3. So S3 is the internet scale, cloud scale storage service from AWS. A lot of customers use it, and they're huge. So they're refactoring all the time for agility and availability and cost and durability and security, et cetera. They're constantly rebuilding it, constantly adding, like replacing parts with new parts to lower that cost structure ultimately. So really a great example of this is the recently announced change from eventual consistency to strong read after write consistency, which was really aimed at driving down cost for customers. So, and by the way, this is with the help of automated reasoning. So in fact, I learned this morning that over at SOSP, it's winning the best paper prize. Another example is EC2. So EC2 is the server in the sky service. So if you want a Linux machine for 6 hours, with 90 processors and a ton of RAM, and then you just want to rent it for that amount of time and let it go, then you'd use EC2. And again, this is EC2's team is constantly refactoring for availability and carbon footprint and cost and security, et cetera. And so a great example of that is something called Nitro. So Nitro is recently, past couple of years, was announced, where they basically rewrote the whole stack. They've built their own microprocessor, they've built their own networking gear, they've built their own hypervisor. So it's a complete rewrite of the virtualization stack for costs, to reduce operations costs, to make it easier to patch, increase security, you name it. And again, that's with the help of automated reasoning. Now, where things get really interesting is that these cycles are composable. So you can actually take 2 cycles and put them together, right? And so Amazon teams are customers of other Amazon teams. So if you're doing work on, even for a virtuous cycle that's only internal to Amazon, it amplifies the customer experience for those services that are customer facing. So a great example of this, and this is an example where the other service is actually customer facing, is the AWS and say Amazon Prime. So any improvement that you make to AWS also improves Amazon Prime. It makes it more secure, it makes it lower carbon footprint, it makes it cheaper to operate. And so thus all the automated reasoning work we're doing on AWS is also having an impact on Amazon Prime. And so you can think of Amazon as composed virtuous cycles. And what's really cool about this mindset is that, well, there's two things I think are really cool about this. So first of all is that all you need is success with one, right? Just find one business unit in Amazon and have success with formal methods, and you've impacted them all because they're connected up and using each other. But the second thing, and this is really dramatic, is that they copy each other's best practices. So if you have success with one, what we've seen is that begins to spread. And so that's a piece of why we've been so successful. Now, another fascinating thing is that you can think of science itself as a virtuous cycle, and you can plug that into the Amazon model of virtuous cycles. So it can increase the technology. And so we're currently receiving billions of requests daily to our proof tools. And so that creates this fascinating situation where basically every day for a scientist in one of these teams, it's like SMT comp or SAT comp or SB comp or what have you. So in those teams, new scientific questions are emerging that we're looking at frontiers that were just unimaginable before. So the tools are strained under the queries and the volume of queries that we're getting, and so that makes for a really fascinating scientific environment. So we're in this sort of I think a real golden age where we can refactor using this idea of lowering the cost structure. So this is where I think things are going to get are really historic now from a scientific perspective. So we have now economies of scale which make it really easy to fund new science on algorithms and radical new infrastructure that really would have been unimaginable before. So as an example of the sort of thing that I've been thinking about, so this is a graph of all of the SAT solvers, the winners of the international SAT competition from 2002 to 2020, running on the same hardware and benchmarks. The benchmarks are the SAT competition 2020 benchmark suite. And so you'll see that basically every year they're getting better. And then the KISSAT 2020 is really, really good. So that was the winner of 2020. But look at what you can do with extra machines. So this is cheating slightly. So the other solvers are all sequential or aimed at sequential machines, but Malabmano is a distributed SAT solver. So it's running many copies and it's sharing conflict clauses across the network. And it's able to solve double the number of the sequential. And so, you know, like if you think about if you give it a specific query, that means this solver is going to be able to solve that query much faster. So we can get, with this setup, we can get better utilization, better throughput. So this is an example of where that refactoring drives whole new scientific ideas that really wouldn't have been possible before with the data to drive that kind of research. So that's pretty amazing. So we're now exploring algorithms that just would have been unimaginable before. And then maybe we'll be in a situation if we can hit the scale where custom hardware begins to make sense. And this, other teams in Amazon have hit this. So EC2, what they ended up doing is they ended up writing their own ARM microprocessor to run on the networking gear. And then they're like, oh, look, we could just expose this ARM microprocessor directly to customers, offer it way cheaper. And now customers are piling in on that machine. So watch this space, right? So I think there's going to be exciting science coming. So, why has Amazon been so successful and others haven't? I think a part of the answer is because it's just a fundamentally different kind of business. So many of us who've worked in industry before, we're working for high profit margin businesses. And, I didn't think about it when I joined, but I joined a low profit margin business, which sounds like a terrible idea, but it turns out to have been a great idea, right? It's this virtuous cycle idea is very compatible with how we think about automated reasoning research. So now I'm going to try and pull out the thinking outside of Amazon. So I think the key here is the thing that I've learned, and I think is important if you're doing work in this kind of space, is that you can get huge multiplicative effects if you can find alignment between the science and the host organization's business strategy and problems, and especially if you can take it each organization has weird quirks. And if you can take advantage of them, then you know, things can really take off. So that's the virtuous cycle model. Now let me tell you about the working backwards process. So so past labs, past research labs, including those I've worked in, and I'm very guilty of this too, have really focused on the technology. They've not obsessed about the application. So for example, I worked on termination, but I didn't, and I applied termination to the reasoning about genetic regulatory pathways with Jasmine Fisher, and I applied termination to device drivers, but I didn't obsess about it. That wasn't the thing that was driving me. The thing that was driving me was termination. And you know, that's kind of a natural mindset we have. But the problem is that creates an imbalance in the virtuous cycle. So it's, you know, I'm sure you share my opinion that we love the clever technology, but and you know, I'm not saying don't love the technology, but what I am saying is that creates an imbalance that hurts you. So it slows down the velocity of data and funding. And so then what tends to happen is the science gets sort of stagnant. And so one way to think about it, I think this quote's been really influential to me. It comes from Strachey, where and so I think we can adapt it slightly to what I'm talking about here. So Strachey says it's long been his personal view that the separation of practical and theoretical work is artificial and injurious, that much of the practical work done in computing, both in software and in hardware design, is unsound and clumsy because the people who do it have not any clear understanding of the fundamental design principles of their work. Most of the abstract mathematical and theoretical work is sterile because it has no point of contact with real computing. And I think there's an analogous thing here where you have to be at the intersection of both the application and the technology. If you just work on the application alone, then you don't know what you're doing. And if you just work on the underlying science or technology, then you don't know what to solve. And so Amazon's culture pushes us to maintain that balance. And they have methods for doing that. And they know our psychology. So they know that we're typically obsessed with the technology, not we're in it for the technology and we'll do it for the application. So they have mechanisms to push us to remain balanced. And so you know, I find them really helpful. So an example of this is something called the working backwards process. And there's many papers, and I think there's a recent book called Working Backwards. It's all about this, about the Amazon process. But I think that the easiest starting point is just to read Werner Vogel's blog post on it, which is like, you know, 600 words or something like that. But the idea is that before you start work, you write the press release. You write the press release you're going to send to the newspapers, and you don't just sit by yourself and write it. You shop it around. So what you end up doing in the Amazon process is that you run this by all of the teams that you're going to work with, and you iterate until you reach a fixed point, and that causes you. So you're going to be doing that with people who don't care about formal methods. Maybe you're going to be doing that with people who don't like formal methods, but you're trying to reach consensus amongst all of the stakeholders in the project that you're thinking about doing. And that interpolates the value of your work outside of your sort of formal methods bubble. And so it's really pushed us out of our comfort zone, which has been for the better. So here's a CAV 2020 paper that we would have never written if it hadn't been for the working backwards process. So it's a way of seeing the world that would have never occurred to me in 20 lifetimes if it hadn't been for that process. So, and there's another benefit to the working backwards process I find really fascinating. The working backwards process helps us scale science team and drives collaboration in this really interesting way. So I'm going to explain. So, you know, we're working in all these spaces like devices and programming languages and cryptography and so on. So they're all kind of virtuous cycles. And then we have many, you know, here's the principles. Of course, these teams are much bigger than this, but, and by the way, this is not who these, you know, not these people are not necessarily partnering up together. I just randomly threw pictures on the screen, but the idea is we have people spread around working on different things. And so the question is, what's the incentive for these different scientists to collaborate? And The answer is that often the different virtuous cycles are combined and are sharing tools via as in a customer relationship. So what you get is you often get two science teams working together, where one is pulling and one is pushing the technology in a sense. And so what we're seeing is really great collaboration between those teams in a way that I've never seen before working in other. You can look at my CV and see all where I worked, but I've never really seen this kind of thing before. So an example of this is Rustin and Zvonimir, who come from different teams. So Zvonimir is in the identity and authorization team, and Rustin's in the platform team. And so Rustin's working on Daphne, and Zvonimir is using Daphne. And they together worked on counterexample generation because Zvonimir needed it, and Rustin knew some of the tools. Another example of this is Dejan and Bruno. So Dejan's working in the IAM Access Analyzer team, and then Bruno's working in the Amazon SMT Solver team. And so Dejan's using the SMT Solver, and Bruno's operating or fixing the SMT solvers. So then there's a customer relationship, and they're working together on a 0 timeouts goal for Dejan's service, and that is driving them into really interesting scientific domains as they're sort of walking the last timeouts out of the way. So the other thing that's interesting about this is that so each team works on behalf of their virtuous cycle they're working in, and then they collaborate when needed, right? And the working backwards process glues those relationships. That customer oriented, why are we doing this method, connects teams that you wouldn't see in other organizations I've worked in. So the other thing that's really interesting about this is that movement is easy and encouraged. So you see people switching around, right? As their interests are, wherever they want to work on, they can move around, no problem. And that makes the management really decentralized. So it's driven by customer need, not fiefdoms. And that's what I've seen in other organizations where people join because of the boss. They don't join because of the organization, and thus they're sort of trapped in that boss relationship. Whereas here, people move around and they're working on different things. Okay, so the question is, why has Amazon been so successful? So I think another piece of the reason is the working backwards process. It keeps this virtuous cycle balanced and speeding. So because there's balance between the focus on customer experience and the technology, then the thing can spin faster. It's not out of whack. And it also drives collaboration. It takes, when you have these two virtuous cycles connected, it drives collaboration between those teams. Okay, so then, pulling this out of Amazon context, so it's counterintuitive, but if you obsess about the application, the technology investment will follow eventually. So it's counterintuitive, but if you love the technology, you're going to starve. And if you love the application, you're going to have tons of resource to work on the technology, which of course we all love too. So since we are technologists, we've made various career decisions to get us where we are. You're obviously the sort of person who loves technology. You have to kind of love the application too, to then get the funding to work on the technology. That's at least how it works at Amazon. Okay, so then the next item is this continuous delivery model. So Amazon pushes for incremental continuous improvement rather than moonshots. And so this idea of moonshot, you'll hear of other research organizations saying, we do moonshots. And this anti-moonshot view is sort of actually quite sympathetic to the automated reasoning scientific crowd. So it's very sympathetic. The Amazon view is very sympathetic to how we do science with these competitions, where we're ultimately working on undecidable or intractable problems. So we're sort of aware we'll never solve the problem. So the only thing we can do is make the tools better and better and better. And so then we use these competitions to sort of raise the bar on that. And that's actually a very Amazonian view. So imagine I say, I want to go to the moon. So the typical Amazon perspective would be like, okay, but let's build a moonshot ladder. Okay, and what's a moonshot ladder? So it's a series of steps to the moon. But the really important thing is that each rung of the ladder should be something that you actually give to customers. Okay. So the customers need to like it, use it, get value out of it. You can't just build the perfect thing and then hand it to the customer. You have to continuously, incrementally give them tools and then keep building on that success in this model. So we, in 2016, 2017, we gave a very crafty early version of this tool called Zelkova, which ultimately led to the IAM Access Analyzer and S3 Block Public Access and IoT Device Defender and all these other tools. But it was really, really, really crafty. But we Goldman Sachs, LogMeIn, Bridgewater Associates, that's the world's largest hedge fund, began using it. And they began using it early. And here are talks on YouTube where they're talking about their use of it. So they gave us a lot of feedback and they were big supporters of it. And they went to other customers and told them that they should begin using it. So it really grew virally because we threw this early tool out there. So every little bit of success with the customer drives more investment into the science, and every bit of advice or mindset model correction you get when you're talking to customers influences what you're doing in the science, and that we find that really useful. And you just iterate that forever, right? So you do it a bit more. They could like it even more. So we launched IAM Access Analyzer. Here's the press release that we wrote before when we were scoping out this project. And then we had really strong demand from customers. So here's a bunch of customers watching a formal methods talk. And then they like it and they talk about it on Twitter, and that just continues on. And then so the other thing is that the operation of the technology is really crucial. So there's the idea of something called a correction of errors, or COE. So basically the idea is it's basically like a SAT style conflict clause database for the organization. So the organization likes to move super, super fast. And then what they do is they say, when they get into a corner that's not a great place to be, they learn lessons from that, root cause it using the 5 whys process, and then synthesize the conflict clause that then they add into the database, which is called the COE database. And so what I do, a lot of, like what I did, especially early on when I first joined Amazon, was I looked through this database of all the past errors and all the past root causes for those errors. And that helps me prioritize what to work on. So it's an interesting shared experience database that's driven by this idea of continuous improvement. And so this process will probably invariably take you to unexpected places. So it's very unlikely you'll end up going to the moon. You'll set out to go to the moon, perhaps. You'll build the moonshot ladder, but right away you'll start getting feedback and you'll realize you actually need to go to Mars. And so that's a pretty interesting process. So here are 3 papers that I just really couldn't have imagined we would ever write, right? So one is on using unsat cores, or it's not quite unsat cores, but I'm going to oversimplify and say unsat cores for debugging of customer networks. Another one is automated reasoning techniques for threat modeling. And the third is how to put an SMT, so the engineering to put the SMT solver into S3's highly available API. So whenever you do a attach policy API request on S3, it actually calls SMT solvers. And if you think about it, that needs to be highly available. We're talking milliseconds of performance, and suddenly it's running in an X time algorithm under the hood. So there's some engineering challenges there. And then another thing that we saw was that customers tell you really fascinating things. So here, one thing we began to hear really early on from enterprise level customers, particularly the more senior people in the enterprise organizations, is I don't care about bugs. Because we were like, oh, we can help you find bugs. They're like, don't tell me about bugs. They're like, what I want to know is what's true and untrue of my organization's systems. And if you think about that, they're asking for soundness, right? Which is really not something I would have expected. So I remember at Flock 2018, there was a sort of a session with different formal methods in industry. So different people working in different companies. And several people were like, bugs are the most important thing. And I was like, no, customers don't care about bugs. And I realized later on that the difference is that if you're talking to a programmer hands-on keyboard, they often really do want bug finding. But if you talk to the enterprise organization, particularly the people running the organization, they want to know what's true and untrue. And so it's a different persona. And so you can start to have these really interesting conversations which influence the technology you do. So why has Amazon been so successful? I think another piece is this continuous delivery model, which, you know, gets us very frequent customer interaction, which increases the velocity of the cycles. And then when you combine that with the working backwards process, it increases your strategic decision-making ability. So for each of these rungs of the ladder, you're typically writing the press release and achieving consensus across the organization about what that's going to be, which then makes you make great decisions. And so the fidelity of that process turns out to be super important. So what's the outside of Amazon lesson? This idea of just like setting some insane vision and going for it, I mean, that's fun, but keeping in mind this continuous delivery model, where rather than building the perfect tool and never quite releasing it, it's way better to very, very quickly get something out there and then just keep iterating on it and you want that customer feedback, because that's where the interesting science will be. That's my experience. So it takes you to really surprising places quickly if combined, you know, with something like the working backwards process. Okay, so then the last thing is these leadership principles. So you can find these on the internet, and it cannot be overstated how much the leadership principles are the DNA. It's really shocking how much this is how the company is run. So there's 16 of them. I'm gonna give you one here, and then we'll talk about some of the others. So one of them is called bias for action. And the idea is that speed is more important than precision in many contexts. So, you know, many decisions are reversible. So if they're reversible, don't spend a lot of time thinking about it, just make a move. So calculated risk taking is sort of where your mind should be. And so really it's basically non-blocking concurrency for human beings or organizations. So that's just one of them. We'll talk about some of the other, but I wanted you to sort of have an idea of what it is I was talking about. So the job interviews at Amazon are based on these. The promotion process is based on these. The employee performance measurement process is based on these. And I hear them mentioned every day, every hour. This is like people at Amazon they talk through the lead, they refer to them, this is how it structures their thinking. So the goal of the leadership principles is to distribute decision-making as deeply into the organization as possible. So to the leads, they want the people, hands on keyboard, or these small teams to be making as many of the decisions as possible. They don't want a top-down organization. And yeah, so I already said that. So, so you can think of Amazon as a distributed system built with people and teams. So here are all the leadership principles. There won't be, I mean, it's probably not very interesting to talk about them in all of them through detail. What I'm going to do is just go through a scenario or two. So, and what I'm highlighting here is the difference between working in this organization as opposed to other places where I worked. So imagine, you know, I say, we should be, I'm talking to someone new, we should be using automated reasoning. And they're like, get off my turf, you know, screw you. You know, in most organizations, that would be it, right? You're not going to work with that person or that team. There's really not a lot you can do. I mean, there's some things you can do, but it's just going to make things worse. So in many respects, it's probably just better to, you know, go work with someone else, and then maybe they'll figure it out, or there'll be some reorg or something like that. But what you can do at Amazon is you know, bring up customer obsession. So you're like, whoa, but in a nice way. It feels like we should be looking at what customers want as opposed to your own personal view, or your emotional view, or your political view, or your fiefdom view. And what that does is it causes a much more positive discussion. So because they know that the promotions process and the annual review and everything, the whole culture is based on this, they're going to be like, oh, okay, they're going to come to the table. And they go, okay. What's the customer need? And now you can have a data-driven, unemotional discussion about whether or not some aspect, should we be using Clock-Theory Improver, or, you know, CVC4, or, you know, like what are there different tools or techniques, and what's the risks, and it may be that you end up not proceeding, but probably for good reasons as opposed to emotional reasons. So another example is, you know, like, I don't get it, I don't know what it is, I can't be bothered. That's you know, you've got, and in most organizations, you've got a lot of work to do to overcome that. But here, what you can do is you can remind them that it's a principle of the company to be curious, and that everyone should be constantly learning and constantly looking for new possibilities and taking action on ways to explore and make use of those new ideas. And so what we've seen is a real hunger to understand what these techniques are. And it's because everyone, is strong on this leadership principle. Because when we interviewed, or as a part of the annual review process, this is what we're prioritizing. So you're working with a bunch of people who are really curious, and so they'll want to know. So most people in Amazon are strong regarding these principles, and that it cannot be overstated how important that is. This makes it so much easier to do science and to get application of your work. So just a few more, I'll just do this really quickly. So, imagine they say, can we get away with less? That's not insisting on the highest standards. And, no one else does formal verification in software. Why should we? Well, that's not thinking big. Thinking small, if you think we're never going to prove the program correct, then we're definitely never going to prove the program correct. So, thinking small is a self-fulfilling prophecy. And another, it's like, oh, people usually don't notice if there's a bug. That's not earning trust, right? So that there's sort of canned comebacks to all of the normal things you hear when you're a scientist in the automated reasoning space, and that diffuse those sort of toxic comebacks. So that's pretty cool. So I think the leadership principles, they make collaboration much more productive and easy as we try to achieve group consensus and quickly iterate to build and operate these virtuous cycles. And so remember that one of the things I want to do is to help folks sort of early career. So I'm gonna try and make a connection here. So here's your science career, and we've got time, and then the amount of effort you expend during your career by time, and the impact. So you first started your career in programming languages or formal methods or something, and that grows over time, and then as you start to get old, and then you eventually die, right? So eventually you're going to stop putting in effort. But the impact, you want the impact of your work to grow, right? So you kind of have this interesting phase where the early stage of your career, the impact is totally proportionate to the amount of energy you put in. So you work an extra hour, you're going to get an extra hour's worth of impact. But as you begin to hit your mid-career, you're going to see, or hopefully see, that the impact is that there's more impact than effort, and that hopefully just continues to take off. So you're looking for a high, effort to impact ratio. So this is a good career. This is a brilliant career because you're getting a higher effort to impact ratio, and this is not such a great career. And so if you want one of these careers, it's more important to join healthy organizations surrounded by hardworking and supportive people than it is to be at the place with the highest IQ people necessarily. That's come as a bit of a surprise to me, but it depends on what you want to do. But if you want your work to have impact, it's really more about the people you work with. Those were my goals. I hope I met my goals. I hope you enjoyed the talk. And with that, I'll hand the floor back and take any questions.
Great, thank you very much. Very inspiring talk. I have questions, but I will let others ask questions. So anybody, if you have any questions, just ask. Yeah, Jandong, go ahead.
Hi, Byron. Oh, very inspiring talk. Just one question. Earlier you mentioned about high margin companies and low margin companies, right? So from the talk, I couldn't tell the difference. Why what you did was successful in Amazon, for example, was not successful in another company, the higher one. What's the difference? I couldn't tell from the talk.
Yeah, I'm still trying to puzzle that out too. I think the thing is that in a low margin company, there's a lot more motivation to refactor. So they're really wanting to, like, Amazon is constantly rewriting all their code. So there's just a ton of proof to do on really old systems. Whereas in a high margin company, they're printing money. So why would they rewrite the thing? It's like, here's my bank details, and they're chilling out with, martinis. But in a low profit margin company, they're constantly like, oh wow, if we rewrite this from Java to Rust, that'll save all this energy. But now they've got code in Rust, or they're like, oh, if we if we use this cheaper RAM, we'll get way better performance. But oh, now we have to rewrite the code because the RAM's faulty. So now they're like trying to write code that's going to work okay with RAM that might be faulty. So there's constantly a need for, like, they want to do really aggressive things because they're trying to get that cost down, and thus formal methods becomes really important. And the other thing is that I think that we might want to think in the formal methods community so one way that resonates pretty well with people I'm talking to is like, they're like, what is it? Someone's like, hey, I don't do math, I don't know what a for loop is, tell me what automated reasoning is. I'm like, oh my God, right? But if I say it's, hey, imagine we want to test exhaustively your system. So how many state holding elements are there, right? And I just run through, and I'm like, whoa, with like 1 million machines, like $1 billion a year, that's going to take many lifetimes of the sun. But what we could use is these techniques from like Euclid, right? And in 5 minutes, get the same result. And they're like, oh, that's so cheap. Wow, that's great, right? So for them, it's, I think, in a way, pushing symbols like in algebra is a really cheap way of doing the same thing that you could do expensively by fuzzing.
Thanks. Yeah. So another question is regarding that the comment you made was very intriguing to me. You said upper management want to know what's true or untrue about the system. They don't care as much about the bugs, right? So in the sense, I think the difference somehow is a bit fuzzy, because if, for example, I run some nice tools, I couldn't find any bugs, that's something true about your system, right? Your system is reliable. Yeah.
No, it's not, because it's not, you can't make a universal statement, right? If they have a regulatory constraint, they're like, data in my organization cannot go through this country, or, or this condition cannot happen. Just saying we didn't find any bugs, hold on, let me close this, isn't especially helpful. Like, I mean, it adds confidence for sure. Everyone feels good, but the question is, if you're the CEO of a Fortune 50 company, there are so many people who want you to do things. There's so many priorities you could be taking. So you're trying to say, what are the top 5 for me? And if someone comes along and says, for very cheaply, I can tell you this thing does not happen, they're like, you had me. But if you just say, we're gonna find 30% more bugs, they're just like, okay, that's cool. I mean, we should find more bugs, but like, now I found 30% more. Do I know anything more? Not really. From a leader's perspective.
I see. I understand.
And the thing is that they're the people paying the bills.
Yeah.
Right. So like, you can charm a developer all you want, and they're like, this is so cool and it's so important, we should do this. And then it's just like, but they don't have the money. So.
Right. Yeah. But making such a statement that you can say 100% true is very, very difficult.
Yeah. Oh, yeah. But that's why we get the big money, right? So yeah. So I hear that from time to time. People are like, oh, but it's so hard to be sound. I'm like, go do testing. There are plenty of people doing testing, but if you want to fly under the automated reasoning proof flag, then strap in. Here we go.
Okay, so maybe related to that, right? You mentioned something SMT solvers you guys are building internally. Is that something like, is this based on CVC4 or Z3 or just totally different thing that?
Yeah, so I mean, currently we're using a lot of open source solvers, but there's a lot of opportunity for distribution, and so one can imagine you run, like, the really common thing is you run 5 solvers, like run Z3, CVC4, CVC5 now, all those different solvers, right? And then just like make sure they all agree, but then you could start to share results, or it may be that for some solvers for strings, there's no bugs, so you don't use them if they're strings, and then just that sort of naturally turns into like, oh, but what if we walked over this formula and found some predicates and subdivide it and turn that into like 1,000 queries and then ran the solvers on those and put the answer back. And so it's more of sort of an eager approach, but that's, I mean, that's the scientific frontier right now in my mind.
Okay, thanks a lot.
Okay, thanks. Peter?
Hi, Byron. Thanks a lot for a great talk.
Thanks.
Thanks also for promoting soundness. Of course, I'm super happy to hear that.
Yeah.
So I was wondering, so many of the principles that you presented are immediately clear, I think at least, how you would use them or apply them in industry. They're a bit less clear how you would apply them in academia, right? For instance, I mean, making each step of the ladder usable, when often finding a user of your tool in the first place in academia is quite a challenge. Also, working backwards requires you have something like a customer who's consuming your research and so on, right?
Yeah.
So I'm very sympathetic to these ideas. I really like them and I try to implement them to the extent that I can, but I was wondering whether you have any thoughts on how to implement those ideas in an academic setting. Is it only possible via industrial collaborations, or do you see other ways as well?
So these are vague thoughts. I don't know if I have great answers for these, but I think that one thing is that this is kind of where the world is going, which is good news for academia, right? Because if you look at like, I mean, you're relatively the same age as me. So you remember a time when it was impossible to get software, like, you know, like, well, when I worked on hardware verification, like you never saw an actual hardware design. So open source has really changed the world. And everything's more porous now. So like from industry, there's way more open source. And so you can prove pieces of code that we depend on. A lot of what we're doing is actually open source. So there's a lot more opportunity. And then the students and people are flowing in and out of academia and industry. So I think that the funding models and partnerships you have, that these ideas will be more familiar. So even in academia, maybe like with Andreas Podolsky, you know, 3 years from now, you're like, let's agree on the press release. And it's in a way, like when I've worked with folks like Andreas before, I wanted to write the abstract first, right? And a lot of people are like, no, do the work and we'll write the abstract the night before. But this is sort of saying, let's agree on why we're writing this before we go off and build all this stuff. So I think that there's ways of taking that and applying it. But one of the interesting things would be if we could get the funding organizations to see the world in this way. Right? If you could say, why don't we give you like micro funding or something? Like, why don't you do these things and then you keep iterating, and then every 6 months we'll give you more and more, rather than these sort of like 10 years of monolithic funding, and you have to like you basically end up doing all the work before you apply for the money anyways. And, so I don't know. Yeah. So one can imagine that government organizations fund more, give people less, and then just see how things go and keep funding stuff that's going well, for example. So that might be something to push on the funding organizations.
Okay, thank you.
Hi, Momcho, go ahead.
Oh, you're on mute.
Yeah, Momcho, you should unmute yourself.
Sorry. Thank you for the interesting talk. My question is probably a little bit as a follow-up to the last question. All of these principles and way of working that you mentioned, they might be very unique to Amazon, right? But we know Amazon is this very super huge company. Do you have any? So my point is, as companies or individuals are starting, in the beginning they work more or less, I mean, individually or on a smaller scale and so on. What is your opinion about that transition? Because when companies in a smaller scale, they may need, they may have very different needs, or the setup may be very different. So what's your comment on that?
So I think the question is, do these leadership principles apply to small organizations or individuals? And yeah, so actually Amazon, if you talk to people about Amazon, for them, this is their attempt to hold on to how things operated earlier on, right? So they were like, they sort of stumbled upon some of these principles. And I think, I remember the precisely, there's this sort of idea of like deciding on principles and then using those is known more in banking. And so actually Amazon comes out of the banking field. So if you look at Bridgewater Associates, Ray Diallo has this book on principles, and like they hand it out to every employee. So this is sort of a known idea. And so what Amazon has tried to do is to simplify them as much as possible to make it scalable to large organizations, such that, you know, you have a company with over 1 million employees that everyone can read that and be like, oh, okay, I get it. So I think that small organizations can use these principles too, and definitely like in an academic setting, you'd want so it might be a research group agrees on some principles, and that allows you to not always have to check in all the time, and also to make decisions and kind of know why other people are making decisions. And when people vector off and do something weird, you can be like, I don't get it. Like, how does this align with the principles?
Yes, I agree. But do you think these principles should stay fixed, or should they be evolvable with respect to the current needs of the company, for example?
So they evolve. So actually there's 2 new ones this year. And so actually the leaders of like the C-suite folks, this is in many ways one of the few levers they have. So they don't evolve very much, but they have evolved. So there was one that when I joined, there was one and it got removed, but they sort of folded it into one of the others. And then they added 2 new ones. Sure.
Okay, thank you.
Thank you very much. So I guess no more questions right now. Yeah, thanks, Byron. Super inspiring, interesting talk.